Good. I like where your head's at. What just happened? Find the value of x. Let's, before we do anything, take a look at this triangle. What's so special about this triangle?
It's isosceles.
Hey, how'd you know that, Teresa?
Because of the two marks on the two sides of the triangle.
Good. It's isosceles because of those two marks. Now, what does that tell us about, what do we call this side down here? What is this side called?
The base.
The base, okay? So this is now the base. And the two angles that are on that base, that 72 degrees and the other angle, what do we call those? This one and this one.
The base angles.
Base angles. So remember, Samantha, the legs are the two sides that are equal. So like this would be a leg, oops, over here. And then this would be a leg over here, right? Okay. The base angles. Now, we talked about this yesterday. What's so special about base angles in an isosceles triangle?
They're the same, number.
They're the same measure. Very good. So this one, very good. They're the same measure. They're the same degrees. So this one has to be 72 degrees. What does that tell us about, but we still don't know what this angle is, right? Can we figure it out? What do you guys think? Can we figure out that angle or no?
Yeah.
How, Reynold?
From adding 72 together and subtracting it by 180.
Very good, because all three of those angles have to add up to 180, right? So 180 minus 72 minus 72. We're going to get 108
36.
minus 72. Yeah, I think it is 36. No, 34. Hold on. Nope, you're right. It's 36.
Is Kale and Warren in class?
No, he's on Zoom.
He's on Zoom?
Yeah. So that angle's 36 degrees. Okay, now we wanted to find x, okay? So we somehow have to sort of translate this over. The only thing about this triangle that we know is that this side and this side are equal. So Samantha, what kind of triangle do we have? Isosceles. Was that your question or?
No, where did you get the 108 from?
Okay, so 170 minus 72. I'm sorry, 180 minus 72 became 108, and we still had a minus 72.
Oh,
Okay. Okay. And then, so it's isosceles, so we know this angle has to be equal to this angle. Why? Because they're the base angles, right? And we already know, remember how this was, this angle here, we knew it had to be the same as this angle down here. These two had to be the same, because that's what it gave us in the beginning. So we can just go ahead and fill in that this one's 72 degrees. And then this one must be 72. So guys, what does x have to be equal to? 36. X equals 36 degrees. Any questions? All right. Now for the tricky one, number 2. Does anyone need more time copying down this triangle in this example? Okay, let's move on to number 2. If I ever am moving too fast, guys, feel free to just slow me down, okay? Just be like, hey, I need more time on that one, or whatever, okay? All right, why is this triangle special?
Because it has a fraction.
Yeah, but what about the triangle itself? What's so special about this triangle?
Is it a cube?
It's an isosceles.
It's an isosceles. How do we know it's isosceles, guys?
Oh, the
The 2 legs.
Yeah, 2 legs, right? 2 of the same side, okay? So this is our leg, and this is our leg, okay? So this angle up here is the vertex angle, and then these 2 are our base angles. What do we know about base angles in an isosceles triangle?
They're the same.
They're the same, so this is x over 2 as well. Okay, now, what can we do to find x? This was the tricky part. What can we do to find x? Anyone figure it out?
You put 180 over 2.
Ooh, close, close. We do something with 180. I like where your head's at, Karen. We do something with 180, but we should come up with an equation. 180 is going to be equal to what?
X over 2 plus x.
X over, oh, okay. Oh my gosh, I almost freaked out. Okay, x over 2 plus x. That's it?
plus x over 2.
Ah, why, Samantha?
Because
There's
there's 2 of them.
2 of them, okay? And remember, 180 is not equal to 2 of the angles inside of a triangle. It's equal to all 3 of the angles added up, okay? So now we're just going to go ahead and solve this. What's x over 2 plus x over 2?
3x over 2.
Close. Let's think about it like this. Let's put the x over 2's together. Plus 1 over 2x plus 1 over 2x, right? A half plus 1. 2x, okay? Because remember, 1/2 x plus 1/2 x is equal to just x, right? If you have a half and you add a half, you get just 1x, okay? And then you add that with the original x and you get 2x. And now all we have to do, oh, Karen, I see what you were saying now. You just divide by 2. So what should x be equal to? 90. Very nice. Now I see it. All right, questions on the warm-up. Anything didn't make sense? Can I go over anything again? Or are we good to go? All right, guys, now this thing, okay? We've got chapter 5, section 5. Guys, we are 2 sections away from being done with all the material that will be on your test, okay? So this section and tomorrow's section, and then you guys are ready for your test. You can study over the weekend, and we're reviewing on Monday and Tuesday, okay? So 5.1 to 5.6 will be on the test. Here we go. Prove triangles are congruent by SSS and HL, okay? So, do you remember how we did, we've only known about SAS so far, right? Side angle side. SSS is side, 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 okay? So write that in there. This is side, 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 and this one is hypotenuse and a leg. So there's going to be two more theorems, right? Where we're not given all the information about a triangle, but we're given enough to conclude that they're congruent, okay? The side one is pretty obvious, right? If all three of the sides of a triangle are the same length, then the triangles are congruent, okay? But the hypotenuse leg one is a little bit tricky. But we'll talk about it. Okay. Side congruence theorem. If three sides of one triangle are congruent to three sides of another triangle, then the two triangles are congruent. Pretty obvious, right? But the application is where it gets a little dicey, okay? So we're going to do plenty of examples just to reinforce this theorem, okay? Give me 1 second, guys, while you guys copy this down. Is this the one? No. Is this the one? No. Where is it? Oh. I think I have it. Okay. All right. Okay. Anyone need more time on this slide, or are we good? Decide whether the congruence statement is true. Explain your reasoning. Are triangles DFG and HJK equivalent or congruent? Yes. Why?
Because they have the same amount of lines on each side. Like for FD, it has 2 lines, and for JH, it has 2 lines.
Good. Yep. We can just prove it by, we would just write S theorem and just put congruent. Okay? They're congruent because all of the sides are the same. We just learned this theorem, okay? Now, what you do want to do is make sure that they match up, right? So, for example, if we start with D, we start with H, we move to F, we should move to J, and then we move to G, we should also move to K, right? So they match up, right? As long as they're corresponding, then we can say that the congruent statement is true. Don't forget that those corresponding portions are really important too. We want to make sure that all of the points correspond to each other, or all of the vertices, sorry. Okay, next one. Decide whether the congruence statement is true. Explain your reasoning. What do we think about this one? Okay. Remember, for side to be applied, all 3 sides need to be equal on both triangles. What's the length of AC, guys?
9.
Okay. And is AC part of both triangles? Good. So let's start there. So we've got a side from here and a side here. Those two are congruent, okay? Let's move up to BC. The length is 7, so there's another side. Is there a side that's 7 on ADC? AD. And now the last side has to be congruent. The last side is BA. What's the length? 3. What's the length of DC? Is that last side congruent? No. So therefore, these are not congruent. AB is not congruent to CD. Okay, next one. Decide whether the congruence statement is true. Explain your reasoning. Is QPT congruent to RST? Just, yeah, we think so, right? Why?
They're both marked as congruent.
How? What theorem can we apply? They have the same angles, some of the same sides. What's going on?
Same sides.
All the same sides, right? So side, side, side theorem. Okay? Because we've got a side here, which corresponds to a side here. A side here, which is the same, is congruent to this side. And then these two sides are also congruent. Side, side, side theorem. So we can say that they are congruent. Okay, the next theorem that we're learning, guys, is the hypotenuse leg theorem, okay? So the parts of a right triangle. You guys should already know that the hypotenuse is the line segment or the part of the triangle that's opposite the right angle, okay? So, for example, if we have a right triangle that looks like this, this is your hypotenuse, this is a leg, this is a leg, if this is the right angle, okay? Just draw a bunch of different right angles or right triangles and just label the hypotenuse, okay? So remember, your hypotenuse is always the side that's opposite the right angle. And then the other two are called the legs. Okay?
Okay, you can go back now.
You sure? The HL theorem. If the hypotenuse and a leg of one right triangle are congruent to the hypotenuse and leg of another right triangle, then the two triangles are congruent. Okay? This one's a specific case because if they're both right triangles, you already know one of the angles, right? You already know the 90-degree angle is the same for both because otherwise it wouldn't be a right triangle. So that's why all you need is the hypotenuse and a leg. So as long as they're both right triangles, then all you need to know is that a hypotenuse and a leg are congruent, and you can say that they are congruent to each other. So 2 theorems in this lesson, guys. The first one was the side, side, side. And now this one is the HL theorem, okay? So only 2 sides, but it has to be a right triangle, right? And one of those sides has to be the hypotenuse.
Can you please go back up for a second?
Sure. So the last slide?
Yeah, I just had to see one thing.
Okay. Does anyone need more time on this slide? Okay. All right, guys, next example. So JKL has vertices J at -3, -2, 0. K is at 0, -2. We're going to graph these 2 triangles and then show that they are congruent, okay? -3, -2. That would be right here. Oops. Right. Oops. Here. This is J. 0, -2 is right here. This will be K. And L is at -3, positive, or -8. Nice. So 1 down here.
-3, -8.
Yeah. So that would be like right down here. And it was what? L. And then the next triangle is RST, 10, 0. Ten, -3. And 4, 0. This was R, this was S, and this was T. Okay? So in order to prove that 2 right triangles, right, are congruent, you have to prove that a leg and the hypotenuse are the same length. Okay? So what's my hypotenuse in JKL? What's the hypotenuse in JKL? Remember.
Oh, KL.
Good, KL. KL. So we need to prove that KL has to be congruent to what side in RST? What's the hypotenuse in RST? ST.
ST.
Good. Okay. Now, I don't know if you guys remember, but when you find the distance between 2 points, you use the distance formula. Okay. Now, that was a long time ago, so let's refresh our memory. The distance formula, or D, equals the square root of x2 minus x1 squared plus the square root, or y2 minus y1 squared. So if we're trying to find KL, here's one point, here's the other point, okay? So KL equals the square root. X2 will make this one, we'll make this x2, y2, x1, y1, and let's fill them in. -3 minus 0 squared plus -8 minus -2 squared. This will give us KL equals the square root of -3 squared plus -6 squared. KL equals the square root of 9 plus 36. KL equals the square root of 45. Okay, now we want to prove that that is the same or congruent to ST. So we have to do the same thing for ST, guys. So ST equals the square root. Let's make an ST. Let's make this X1 and Y1.
Is Reynolds Bazile in class?
No,
No?
he's on Zoom.
On Zoom?
So X2 is 4. Oops. Minus X1, which is 10 squared, plus Y2, which is 0, minus -3, which is Y1 squared. We're going to get ST equals the square root. 4 minus 10 becomes -6 squared, plus 0 minus -3 becomes 3 squared. And we get ST equals the square root of 36 plus 9, which is ST equals the square root of 45. So this side length is the square root of 45. This side length is the square root of 45. That was the toughest one, okay? But since we've proved that the two hypotenuses are congruent, okay, I'm going to put a little congruence mark. So I'm going to put one line here and one line here, showing that those two sides, of which are both the hypotenuses, are the same length. Now, let's just pick any leg on RST. Let's pick RS. What's the length of RS, guys? The distance between R and S? You can just count them. Anyone? The distance between R and S?
3.
3. Yep. Oops. Is there another leg in the other triangle, JKL, that's also 3 units?
JK.
Good. JK. 3 units. Okay? This is all we need to prove that the two triangles are congruent. Okay? So now we can say triangle JKL is congruent to RST. By HL theorem. This was a long one because of that awkward hypotenuse, okay? But basically, all you need to prove that the hypotenuses are equal and at least one of the legs are equal to each other. And you've got two congruent triangles. We're almost there, guys, I promise. Example 6, is there enough given information to prove that the triangles are congruent? If there is, state the postulate or theorem. They're both right triangles, right? Okay, we know that they're right triangles because of the angle measure of one of their angles is 90 degrees. Okay, that's the definition of a right triangle. Okay, are their hypotenuses the same?
Yeah.
Yes. What is the hypotenuse of the top triangle?
HF.
HF. And what's the hypotenuse of JHK?
KH.
Yep, KH. Okay? It's always going to be that side that's opposite the 90-degree angle. Okay? Kind of like the diagonal side. Okay? And do we have a leg that's the same in both of them?
Yeah.
Yeah, which two? HF, that's the hypotenuse. Yep, GH and JK are both the same, right? So what we can write is, by the HL theorem, we have congruent triangles. Okay, example 7, we are skipping this one. You can write skip on the top. And that's it for today, guys. Your homework is on the last slide. Okay, we went through this
Mr. Yurko, on Canvas it says
pretty slowly, so you guys should be pretty set on the homework.